welcome to Aalto Fablab, and today we're going to talk about 3D printing, or more specifically about the FDM 3D printing, which is more related to the printers that you can see or that you can maybe probably hear in the room where I am right now. So two of them are these, and then we also have this printer, for example. During this session, you're gonna obviously see a little bit more. So what is 3D printing? So 3D printing is a form of additive manufacturing. Additive manufacturing is a manufacturing technique where you are basically putting material on top of existing material in order to achieve things, more like things like 3D models like these, for example. Three most popular 3D printing processes. First one is FDM, or the so-called Fused Deposition Modeling. The story is the following, that in 1988, Scott Crump developed Fused Deposition Modeling, and then he invented and patented it in 1989, and he did it together with his wife. And together they founded a company that is called Stratasys. It exists even today, so they are producing 3D printers and all kinds of things around it. As with many things that we see today with this 3D printer and digital fabrication revolution, so this patent came to an end. Because of that patent, or like a set of patents, because they expired, it gave an opportunity to companies and individuals to actually make their own versions of 3D printers using the same technology. And obviously, after 20 or even 30 years, when this happens, then many of the parts become much cheaper, and many of the ways how to produce these kind of printers also become more available and affordable. And this is why there are these many different brands of lo-fi 3D printers, which for us as beginners of 3D printing doesn't feel so low-tech, like 3D printing. Like for people who haven't been doing any digital fabrication or do not even know about 3D modeling, for example, that somehow feels like magic a little bit. But FDM was not the first. So actually the first technology was SLA, or stereolithography apparatus. And back in 1984, Chuck Hull patented it as a method of creating 3D objects by successively printing thin layers of an object using a medium curable by ultraviolet light. This is from Wikipedia. But we have a few of SLA printers back in the other room, and these are made by a company called Formlabs. I'm going to tell more about that later. And this technology allows you to create rather higher resolution prints. But the problem, or more like the negative aspect of it, is that it's a little bit messy process, so because it involves many chemicals. And then the third most popular technology is SLS, or Selective Laser Sintering. And Selective Laser Sintering, SLS, was developed and patented by Dr. Carl Deckard and his academic advisor, Dr. Joe Beeman, at the University of Texas at Austin in the mid-1980s, under sponsorship of DARPA. So this is also from Wikipedia. And SLS is a technology where you use laser sintering in order to melt layers of powder together into a 3D object. So usually how it goes is that you have a nylon powder or metal powder, and then you put a thin layer of that on a surface, or kind of in a sandbox. And then there's a laser which is going over that layer and melting it together with the layer that was there before. And this is how the 3D object becomes. For the FDM 3D printers, so these ones and then this one over here, we categorize them here in two ways. So basically they're overnight printing printers, which are the Ultimakers, and there are the ones that you can use during the day, which are the LulzBots. the Ultimakers, so this one here that you see, it's the Ultimaker 2 Plus extended. It has a build volume of 223 by 223. This is XY, and then 305 millimeters. So that's the Z volume over here, like that. Ultimaker S3. It's a bit more recent, and it also has a dual nozzle system. So which means that with one nozzle you can print the material that you want your object to consist of, and with the other nozzle you can print the support material, which then can be water soluble or whatever you choose. And the build volume of this one is 230 along x-axis, 190 along y-axis, and 200 millimeters along the z-axis. Yes. So as for the printers that you can access during opening times only, we have LulzBot TAS 6. And this printer has a single nozzle system, and its print volume is 280 by 280 by 250, so almost 30 centimeters cubed, or like 25 centimeters cubed. The other one is the LulzBot Mini. The print volume of this one is 152 by 152 by 158 millimeters. And how to print with those? So here we have several slicers, but the ones that you should use if you're starting out are the ones that are labeled Cura. And for the Ultimakers, so for the overnight printers, we use Ultimaker Cura. And then for the LulzBots, we use Cura LulzBot. Cura Ultimaker you can use for slicing objects for Ultimaker 2 Plus Extended and also the S3. And I'm going to show you how we can slice an object that we just 3D scan. So in order to use these, you need to click on the icon. So here is something that already has been set up. We can go to File, New Project. First things first, you need to select the printer that you're going to be using. And we can select the Ultimaker 2 Extended. Next is to open the model. So we go to Open Files, go to our SD card, and we load Runjit. So, and the 3D scanner actually did scan it in actual size. So if you look at the object and look at the printer next to the computer and kind of try to imagine the scale of this one, then it's approximately the size of your torso. And in order to scale this down, we can use the scale tool that you can access by clicking on this icon over here. We can make it 10% the original size and hit enter. Then we can use the move tool in order to move it around, and so that it's inside the build platform of the printer, somewhere in the center, and it's going to automatically drop to the build platform over here. So by using the scroll, middle button scroll on the mouse, you can zoom in. And next is to choose the filament that you're going to be using. So we are using 3DK Berlin PLA filament mostly. PLA is the when you heat up PLA, it doesn't release too much toxic fumes. So that's the only material that we are using here, and it's very versatile. So if you need to use ABS or nylon for your project and you want to 3D print that, then I would recommend you to go to Vare 3D printing lab. So there is a specific lab which is only for 3D printing, and you can go wild and print whatever material you like there. And here, so yeah, you select the PLA. Then the next is to select the profile. And I recommend you to go with normal because of reliability. So if you need to be very detailed, then you can go with fine and all of that. But what you should keep in mind is that whenever you're selecting this profile, so this extra fine, fine, and normal, and the numbers next to those, these are identifying, or these are describing the layer height. So it's not the XY resolution. The XY resolution is defined by two things. So it's the movement resolution, which can be quite high, so let's say 100th of a millimeter. But the critical part here is the nozzle diameter. So nozzle is this little pointy thing, so like the tip of the metallic part, which is actually being heated up. And then the molten plastic is being pushed through it in order to produce a line of molten plastic. So I'm going to go with normal. Then there are several things to check. So one thing that you might want to change sometimes is the infill density. So if you're interested what exactly is infill density, you can take a look at this sample that is placed, that you can find next to the 3D printing computer in the 3D printing room. And this pretty much shows you how the infill density relates to an actual reality. And usually like 20% is fine. I think like Ultimaker sets it to 18% by default. And another rule of thumb is that the lower the infill density, the less likely your model is going to shrink, because when plastic heats up, it expands, and when it cools down, it shrinks. And the more the build volume of your object consists of plastic, the more opportunity for it is to shrink. So if there's less plastic inside, then there's not so much material to shrink. So your first prints, you probably are going to notice effects like these. So the corners are actually lifting up at the bottom, and sometimes the print is actually getting loose while printing. So that's because there's a lot of volume over here, a lot of volume of plastic, and there's much more opportunity for it to shrink. And apart from infill, it makes sense to check the support tab. Now, in this case, we do not need supports, or maybe we do. But usually for overhang areas like this, for example, it is nice to have some support. So let's actually use the support feature to just see how it looks like. And then once you activate the support feature, then you will see that there are all kinds of additional options. So if you are not yet so experienced, then the defaults are just going to be fine. So when you're fine-tuning your print and you want to get the best results out of it, then probably you will want to play around with those. And the other thing that is important to check is the build plate adhesion part. So usually for simple prints, I prefer to use skirt instead of brim. So I select skirt. And then in order to produce machine code from this 3D model, and in order to understand what slicing actually means better, all it takes is just to press the preview button. And what slicing means is that the software is going to generate paths for the machines, or for this specific Ultimaker 2+ extended machine, for it to move the nozzle and heat it up to certain temperatures and feed it with the correct amount of plastic so it can actually produce this layer. And here with this horizontal slider, you can play back the individual layer, how it's going to be drawn. And then with this vertical one, you can see how the object is going to be built up layer by layer until it becomes a real 3D object. And here, the blue area, so the blue 3D structure is going to be the support structure. So it's going to support the actual object, and we're going to use the same material, but the character of the structure being built is going to be such that it's going to be relatively easy to remove it from the actual structure. I'll just demonstrate to you a few options how it's going to look like if we enable or disable them. So for example, for support, if I click on the checkbox and disable it and then hit slice, the result is going to look like this. So it's going to try printing layer by layer, and the problematic part is going to be here because there's no way that this layer is going to stick because there's nothing for it to stick on top of. So this is called an overhang, and basically the printer is going to attempt to lay out to produce a layer of plastic in plain air, and it's just going to fail. So this is why we need the supports. So, but this is how it looks like without the supports enabled. So I'm going to enable it back. And another thing that I'm going to do is I'm going to change the build plate adhesion from skirt to brim. And as you see, so these concentric lines around the base of the object, so this is called the brim. And what it can do for you is that it can prevent creating these errors with these rounded, lifted corners. So if you, for example, want the object to stick better to the build plate, so you can specify some properties for the brim. So for example, you can increase its width. So in this case, it's going to be 8 millimeters. But the one negative aspect of the brim is that it's sometimes hard to remove. And this is why I prefer to use the skirt. And skirt is not going to help your model to stick to the build plate, but it's going to help to make sure that the nozzle is extruding plastic at the beginning of the print, because these are going to be the first lines that are going to be drawn by the printer. So you see it starts out with drawing these lines, and if there are two lines that are this long, then that's just enough for the printer to make sure that the printer is actually extruding plastic. And in order to transfer it to the printer, the first step is to save it to file. So I'm going to save it on the desktop in the folder 3DP. And as you see, the slicer adds this cryptic prefix to the file name, which essentially means Ultimaker 2+ extended. So it's a short name for the printer. That's what Cura does. Right, and then in order to transfer the file to the printer, you will need the SD card that is loaded into the printer. You can find it here. So when you press on the SD card, it's just going to jump out, and it's going to be possible for you to remove it easily. And then from here, you just do a really elegant move, and you put it into SD card reader here in the computer. Next thing you do is you go to the folder where you saved your job, copy it, and you go to the SD card and paste it. And then you eject it, and then you remove the SD card from the computer and insert it into the 3D printer. Next is to turn on the 3D printer, and you can find the on switch on the back of it. Yeah, and once the printer starts up, then you are being presented with this information screen, so with the main screen of the printer here, so this little interface. And the way you navigate is you use this rotary button, so you can rotate it around and then hit it or press it in order to actually go to the selection that you selected. And here you need to use the same in order to select the model that you or the job that you want to print. And it's going to start printing. As for the LulzBots, you want to use the Cura LulzBot edition, you can find it on the desktop, and you can open it up by clicking on the icon, and once it's open, the icon turns green. And the way you set it up is very similar to how you set up the print on the Ultimaker Cura. So the interface is just a little bit different. First, you select the 3D printer by using the menu on the right top side. So we'll select the LulzBot Mini 0.4, which means that's the LulzBot Mini with 0.4 nozzle. So there is one that is with 0.8. That's a very good one if you want to use the base printing mode. Yeah, we're gonna go with the LulzBot Mini 0.4. This one, and so here also you can select the detail level of the interface. So we're gonna leave it to all, and for material we're gonna use PLA, and for the profile we're gonna use the standard profile, which is gonna print with the 0.25 millimeter layer height, which is 1/4 of a millimeter. And for the setup, so they're the same things to check. So we want to double check the infill, 20% is fine. We want to double check the support. So this really depends on the model that you want to print. And so in order to start, let's import a model. Actually, file, open files, and go to the class scan so we can actually select the cow. Here we go. And again, we can use these scaling tools over here in order to scale it down. Let's say 20% or 15. Yep. We don't even have to move it around, but we could if we wanted. Also, if you want to print multiple objects, there's a function multiply. It's gonna create copies of the object next to it. But in order to add speed, just gonna leave it as it is. And here, I assume that we will need some supports because of these overhangs over here. Let's go to support, generate support everywhere. And for the build plate adhesion, yeah, skirt is selected by default. And in order to slice, you just hit prepare. And we are going to save it to file by hitting this. No. And before we save it to file, we will select the layer view in order to see how it's going to be printed. So, and again, here we have two sliders, one for each of the layers to select the layer, and then the horizontal one, which shows how that particular layer is going to be made. Like so. And in order to transfer it to the printer, we need to first save it. So I'm going to save it on the desktop, 3DP, save. So I'm going to save it as G-code file. In order to better understand what is G-code, we can just open it up in a text editor. And this is how G-code looks like. So this is for the specific LulzBot printer. So as you see, it sends X and Y coordinates and also labels this procedure as wiping. So basically, this is a process of cleaning the nozzle so that it is being cleaned from any leftover plastic before the calibration process starts. So here, yeah, you can follow it up. And then this is the actual printer code. So this is instructions for the nozzle actually go to a certain direction, and then see this E command. It tells the extrusion mechanism to extrude a certain amount of plastic. And yeah, once we have the file ready, we can actually so the next thing for the LulzBot Minis, it is that the LulzBot Minis, they do not have any SD card slot. So the way you transfer the files to the LulzBot Mini is by using the web interface, so OctoPrint. So each of the LulzBot Minis, they have a Raspberry Pi connected to them, and each of the Raspberry Pis, they are basically connected to the Wi-Fi network, and they have their own IP addresses. And so in the local Fablab network, we can access those Raspberry Pis. And each of them, they are hosting like a small web server with one particular website, with the OctoPrint website, and that's the web interface in order to for us to be able to control the printers. And then the Raspberry Pis are connected via USB to the printers. In order to access the printer, we need to make sure that it's on. So we're going to use the LulzBot Mini 4. I'm going to switch it on. And when you open the web browser here, the Chrome web browser on this computer, you will find bookmarks on the top part of the interface. And for the number 4, you should select Chewbacca, number 4. And it's going to open you this neat web interface. And if you're not logged in, then you should click on the login button, click on the username field, and it's going to offer you already existing credentials. Just hit login. And then you need also make sure that the Raspberry Pi or OctoPrint is connected to the printer itself. So in order for it to establish connection, you need to hit this connect button. And then here you need to make your folder. I'm going to create a folder 3DP, enter it, and you can upload your file. And I'm going to go to desktop, 3DP, and make sure that the prefix is the one that fits your particular printer. So LM04 means LulzBot Mini 0.4. So it's the profile name that we were using in the slicer. Open, it's going to upload, so there's past. And once it's done uploading, so this print icon should, print button should become accessible or clickable, and you can click that to start printing, to start the print. And here on the right side in this graph, you'll be able to see what the printer is doing in terms of parameters. So the blue line shows you the target and actual temperature of the build platform. So the blue line that is lighter, that shows the target temperature, and the blue line that is darker, that shows you the actual temperature. You see it's slowly heating up. And the same happens with the nozzle, which is the red line. So the light red line is showing you the target temperature, and the rather darker line is showing you the actual temperature. So in first, it's going to heat up the nozzle in the bed to a level that it can initiate the nozzle cleaning sequence. So next to the printers, you can also find these, and these are characterizing several interesting things that the printers can do. So for example, this one, it characterizes how capable the printer is in terms of generating overhangs or printing overhangs. And then this one shows you how well it is able to deal with bridges. Alright, and here we have the Ultimaker 2 printing. So, and here we can see the LulzBot Mini printing. So that's it for FDM printing. Thank you very much, and see you soon.